You are watching Bloomberg Tech Europe. Coming up, the hype around SpaceX's historic IPO made it the hottest ticket on Wall Street, and proof that the US dominates the race for space. Europe's space industry, meanwhile, might lag well behind both America and China, but it's not backing down as it pursues its own path to space autonomy. Those involved in the mission say success will require an all-hands effort from Europe.
We see now, of course, with the IPO of SpaceX that the support of NASA and the Space Force really leads to world-dominating space companies. And this is something, of course, where volume is just as important as excellence.
We speak to European companies and policymakers leading efforts to develop the homegrown space economy, including Hélène Huby from the Exploration Company, the head of the European Space Agency, and the chief executives of Pulsar Fusion and BioOrbit. Welcome to Bloomberg Tech Europe. In this episode, then, we are asking what is needed for Europe to compete in space and whether any of the pieces are already in place or still years away. Europe has world-class satellite infrastructure. It has Galileo for navigation, Copernicus for Earth observation, and major players like Eutelsat, Airbus, Thales, and Leonardo. But the weakness is access to orbit. Last year, the US attempted around 181 orbital launches. China attempted 92, Europe just 8. Europe did actually improve last year, but Ariane 6 is still not a reusable, high-cadence, low-cost launcher on the scale of Falcon 9. That matters because the new space race isn't simply about rockets, it's about overall control of launch, data, and communications. And the region's strength in satellites is offset by weakness in launch and reusability. Europe's aim is not necessarily to beat SpaceX, it's to avoid being dependent on SpaceX.
I give SpaceX less than a 10% chance of succeeding at all, to be clear. In fact, I told people this. I said, look, we're probably going to fail, but we should give it a try, because if we don't, if there's not a new company that enters space, we will never be a truly spacefaring civilization.
The European Space Agency now has a record 3-year funding package, and private investment is picking up, with European space tech startups raising $1.3 billion in 2025. But the gap with the US remains large. So the risk is clear. Europe could be excellent at building satellites, but still dependent on US launch, US platforms, and US low Earth orbit networks. One aerospace manufacturer developing and operating reusable modular spacecraft and keeping Europe in the space game is the Exploration Company. CEO and co-founder Hélène Huby told me the company's goal is to overcome the barriers currently limiting access to space.
It's all about transportation. Transportation is what is very difficult to master, the highest barriers to entry, so very few are going to succeed. But once you make it, you open space to, of course, Europe, but also as many nations as possible in our case.
What does that full stack in space transportation look like? What is the cadence that you're targeting?
So we've done things a little bit the other way around, because we didn't start with a rocket, we started with the capsule, right? One reason for that is that Europe never had its own capsule. So every time we want to fly an astronaut, we need to give cash to our dear friends of SpaceX. And hey, we could use that money to build the technology here and also to inspire people.
What does sovereign and sovereign space mean to you?
So it means for us in Europe the capacity to be a leading space nation with our own technologies.
How big is the gap right now versus the US?
The gap is significant. The gap is significant, especially in space transportation. We are very good in satellites, but the gap is significant in space transportation. That's why we've also we've been very focused on that, because I want to have an impact where there is a gap, basically, and we can significantly contribute to this European sovereignty. The market is going to go towards very, very big launchers, because on the demand side, you have more satellite constellations, the satellites becoming bigger, and also you have more like exploration demand, and on the supply side you have Starship. So the market is going to go to a very, very big launcher. And if we want to have a capacity in Europe that can serve not only European sovereign demand, but also other countries, because I very much believe in the collaboration across countries, and this is one of the very big strengths of Europe. We've been able to build this collaboration across nations. And with the exploration company, I want not only to reinforce Europe as a space power, but also to scale this collaborative spirit worldwide.
Is Elon Musk an inspiration for you?
So he's an inspiration for many great things he has accomplished. I mean, what he's built with SpaceX in terms of products, it's outstanding. And if you want to build something that lasts and something which is among the best in the world, you need to be inspired by the very best. Like, you're a componist, you're going to listen Bach and Mozart and etc. So like you can really like write the best music. Doesn't mean that you're going to write the same music, right? So this is exactly what we're doing. We are, with humility, learning from the best while building our own style. And we don't want to occupy Mars. We want to build a space future which is more peaceful and more collaborative.
Is SpaceX a catalyst or a major challenger?
I hope they will become a major challenger, because then it means that we will have become also a challenger.
Let me push you on the timeframes then.
Yeah.
To get to the point where SpaceX is with their reusable rockets. What timeframes are we realistically looking at for the exploration company? Is this something achievable within this decade, Hélène?
Absolutely. Within this decade, absolutely. We plan to fly to the International Space Station with our cargo capsule in November 28. This is the date we have in the schedule right now. So we might have a little bit of delay here and there, but the team is working very, very hard to make it happen. And so far, since company creation, we have accumulated about 10% of delays on all of our programs. We've delivered all of our programs on cost, and we've met our cash target every quarter but once. So it gives you some data points. So I hope we continue that way. For the rocket engine, we again have an aggressive planning, which means we might be a little bit late, but like, because you have an aggressive planning, it means you're going to reach your aggressive goal with like more probability than if you have like a very comfortable planning. So we plan to perform the engine demonstration test end of 28, again very aggressive, and then in the business plan that we're sharing with the investors, we plan to fly this very big rocket in 2033. Again, it's aggressive, but this is benchmarked on the industry. You take the best, you take SpaceX, you take Rocket Lab, and you look at how much time they needed to build the rocket and then to build the next generation of the rocket and bigger rockets. We are within this benchmark.
The exploration company's CEO and co-founder, Hélène Huby. Now, the man who oversees Europe's space agenda is Josef Aschbacher, the Director General of the European Space Agency. He acknowledges that while the United States is an important partner, Europe needs to do much more as it pursues greater autonomy in space.
One is never comfortable with any dependency, because you always have to evaluate, what does it mean and how much independence or autonomy you want to achieve for Europe. And this is something that I have discussed with the ministers just last year when we had the ESA ministerial conference, which brought a record budget for ESA, 22.3 billion or 31% more than the previous ministerial conference. And the argument of independence or autonomy was a very strong one, that we need to build up our strength, not to be isolated and to be, I would say, alone with our capacity, but really being a strong partner, also for international partners in the US, in Japan, in the UAE, in India, and in other countries. So this is really something where we build up our strength, more autonomy, but also more autonomy to be a stronger partner in global space programs, of which we are having quite a large number.
And to your point, you have successfully increased the funding now available for the European Space Agency as you coordinate all of these efforts. Is it enough, though? Is Europe doing enough to fund its space economy and its space industry?
No, it's not really enough. I mean, we have made huge progress, and the success was quite outstanding, as you mentioned. But if I compare the figures of public funding in Europe with those in the United States, for example, which is always our benchmark, the United States is spending 6 times as much as in Europe. So if Europe has 1/6 of the public funding, that means in Europe it is the European Space Agency, it's the European Commission, it's national agencies and member state activities, then if you only have 1/6, you can be brilliant and excellent, but of course with much less money you can never achieve the same. Or the other way around, of course, if you have much more money at your disposal, you can develop very different space companies. We see now, of course, with the IPO of SpaceX that the support of NASA and the Space Force really leads to world-dominating space companies. And this is something, of course, where volume is just as important as excellence.
Is SpaceX good for Europe or bad for Europe, a challenge for Europe?
I mean, first of all, SpaceX is, of course, a US company, but it operates globally. I take a lot of inspiration and a lot of motivation for Europe to really see what can be done with a very, I would say, a very ambitious, a very aggressive schedule and a very aggressive set of goals. So I have been in SpaceX quite a few times. I know their factories, also the leadership pretty well. We have also interactions and cooperation with SpaceX. For me, it's really something that helps us also in Europe to say, look, this can happen if you do a number of things right.
And above and beyond funding, and maybe that is key, what would be your 1 or 2 priorities in that clarion call for governments around Europe to support this ecosystem, the incumbents and the startups? What would you prioritise to them? What would you say needs the most urgency right now to support that ecosystem?
What is needed is always funding. This goes without saying. But what is also needed is acceleration. We need to be simpler, faster, sometimes a bit leaner in the processes, and certainly avoid fragmentation. That means that member states within Europe, of the European Space Agency, have to work together in one common project rather than doing it nationally, because fragmentation also weakens us. And in times like these, where security pressures, economic pressures are so high, we need to stick our heads together, and united we can be extremely strong.
OK, that was Josef Aschbacher, Director General of the European Space Agency. Coming up, I speak to the leaders of 2 firms making big bets on the growing space economy. We're going to hear from Richard Dinan from Pulsar Fusion about his ambitious plans for orbital energy, and Katie King from BioOrbit joining me in studio to discuss developing new medicines in space. That is next. This is Bloomberg. Welcome back to Bloomberg Tech Europe. Now, Pulsar Fusion is a British company that builds Stage 2 propulsion systems. These kick into gear once a rocket has delivered its cargo or satellite into orbit and are designed to operate in the vacuum of space. I spoke to CEO Richard Dinan about making the economics of space work from the UK and his ambitious plans to develop fusion power in space.
So for us, we need to be in a situation where we're delivering 30 engines a month to clients, which doesn't actually sound like a great deal. But these engines have to be built in a clean room here in the UK. They then have to be qualified in a vacuum chamber and delivered to various client satellites. So doing this at scale is the challenge.
And you will be shipping these products from next year. Can you tell us about your clients, your customers? What is driving that demand?
It's the demand of, as the access to space gets cheaper due to launch technologies improving, it means that all these nations are looking for their own sovereign capacities of satellites, and whether they want their own Starlink or they want their own constellations. All of these satellites need their own engines. On top of that, as the market starts to look at a cis-lunar economy, or even a cis-Martian economy, and people deploying assets further out into the solar system, all of these depend on their own maneuverability and their own stage 2 engines. So I think the market has never had such a demand, and I think it's actually the supply of engines that can restrict what missions are possible at the moment.
To what extent has the innovation that we've seen at Blue Origin, at SpaceX, the focus on data centers in space, been a catalyst for your business in terms of driving interest, in terms of driving customer interest, investor interest?
I mean, it's been absolutely enormous. I think, as you know, we've been doing this for 15 years now, and I can tell you that I think suddenly seeing that the appetite, we know how many times have we used a satellite today on the way in, you know, for just getting here, for checking the weather. Several mobile apps are using their own satellites, and a lot of this technology needs to be replaced. So again, for England, this is a very big opportunity because we don't have a launch provider like a SpaceX or a Blue Origin, but we do have the skill set to manufacture these stage 2 engines and the plasma physicists and the sort of key personnel and talent pool. And it's Pulsar's ambition to be the first company to do fusion in orbit, and we have every chance of doing that.
This is fusion in orbit by 2031 is the target.
We want to demonstrate fusion in orbit by 2031.
Okay, that was Richard Dinan, CEO of Pulsar Fusion. So from energy in space to medicine in space, UK startup BioOrbit is making a bold bet that by sending drug making towards the stars, it can help save lives and billions of dollars potentially from health providers like the NHS, and potentially pave the way for novel cancer treatments that are easier to use. The company has a lofty goal. It wants to harness weightlessness or microgravity to produce protein crystals that could pave the way for cancer treatments that people can inject at home instead of receiving by IV. In March, BioOrbit won a £250,000 contract from the UK Space Agency to develop the technology. Katie King, BioOrbit's co-founder and CEO, is with me now in the studio. Katie, thank you for coming in. When I was talking to people about what you do, people who are not in your space, in your sector, excuse the pun, there was kind of befuddlement. Wow, that sounds like science fiction. But you have come through with a really important proof point just in the last few months. Talk us about the progress that you and the team have made.
Great. Hi, Tom. It's great to be here. Thank you for having me. It's a really exciting time for BioOrbit. We just launched a record-breaking mission to the space station, producing the largest scale production of protein crystals in a space environment by one order, if not two orders of magnitude. And this is a necessary stepping stone towards taking those cancer treatments and enabling them to be self-administered at home.
Why is this so important, and what can space allow you to do that we can't do back on Earth?
So to get a self-administered cancer treatment, you need to take all of that drug from that IV bag and get it into a small pen, tiny, tiny volume. And that is a huge challenge to do. The solution to that is making crystals of these drugs, and it can get it really concentrated in that small volume. The problem is that gravity inhibits that process, so we cannot achieve that quality of crystal here on Earth. We need space to make that happen. So at BioOrbit, we are taking it from small-scale R&D into a scalable production of these crystals so that we here can benefit from it.
OK, so you sent these up. They've come back down. They were up there for about 6 weeks in space, launched via SpaceX. You're now analysing what you were managed to achieve up there. Success, what does it look like? How does it set you on the path going forward? What are the next milestones that you hope to achieve?
So with this mission, it was successful with what we set out to achieve. We have shown that crystals can be produced in a continuous way that's scalable for the future. So this is a massive step change for the industry away from this experiment into production. And so for us now, the next step will be to test the capabilities and the limits of the system. Crystals can bring benefits to a wide range of drugs, not just the oncology drugs. So we really want to see which of these other markets that we can also bring benefit to. OK, so you talked about scalability, because cynics would say that that's one question, is how do you scale this? And they may also bring up the question of cost. How do you make this cost effective? How do you respond to those? Yes, so when we think about factories, we think of massive football field type factories. The fact is that for this, we're just doing the crystallization step. So the factory is about the size of a microwave. And so to hit global scale production of these crystals for, say, Keytruda, world's best-selling drug, we would need maybe 10 or 15 of our microwaves to then be able to form the correct quantity of these crystals. So that's possible. And with how infrastructure's changed and cost of launch and cost of return has plummeted, scale is possible. It's not science fiction.
What is the timeline then between what you're doing now, the progress that you've made, the proof points that you've achieved, and us actually getting access to drugs that have at least partly been made and produced in space?
So before anything can be given to a patient, to a human, everything must be regulated.
Yes.
So we have to produce these drugs just in the same way with regulation as any other drug that's produced. And so that's the first stepping stone. We're working with the MHRA, with the Regulation Innovation Office, UK Space Agency and CAA about this roadmap to what does pharma production in space look like. And the UK is leading globally on this.
Are regulators aligned with your vision? Are they proactive?
They are incredible. The UK has been fantastic. Yes, they are backing it, and we see the benefits of this and want to make it work. So again, we're working with the regulators so that that is possible, and that is really where the UK will win.
Okay, so in terms of getting these drugs onto the market, are we talking early 2030s potentially?
So we have to go through these trials first. Yeah. So for regulation by the end of the decade, and then we can go into these human trials. So then it will depend on if we're taking a drug that's already in existence, then that's an accelerated process. If it's a novel drug, it will take a bit longer, but we're looking at 10 years.
Okay, about a decade away. Are you partnering with pharmaceutical companies? We've obviously got some significant strengths in the UK when it comes to pharma. Is that something that you're working on?
That is definitely something that we're working on. Again, working with Big Pharma to then bring about and unlock these new drug formulations for their pipeline and their portfolio.
Okay, what is the investor appetite? You're backed by the likes of Local Globe, who are really significant investors, particularly in deep tech. Are you raising capital again? It's capital intensive, presumably. What is the state of funding right now?
So because we're just focusing on the product and we're not doing end-to-end, the capital required is less than if you were building a rocket company.
Okay.
So that's a really key point because the infrastructure's there. We will be raising at some point in the near future, again, to take us to our next step, to then scale and then to be able to work with all of these pharma companies. So that is the next step for us.
Okay. You work with SpaceX very closely. Are they a good partner? Do we need a SpaceX? Do we need the exploration company, what Hélène Huby is doing? How important would that be for your business?
It's so critical. It's infrastructure. And once the infrastructure's there, they are effectively being our courier system to space and back from space. So then companies like BioOrbit and others can then use that infrastructure. They don't need to build it themselves and then bring about the new markets and new applications of using space.
Okay, so you're at the application layer, they're at the infrastructure layer. Europe needs to play its part as well. You're focused on oncology right now. Do you expand that portfolio into in the future? What are your ambitions beyond the oncology?
Yes, so again, the benefits of crystals, one of them is to then turn IV treatments into self-injections. Another one is extended release rates. So if you have injections that you have to typically take daily, through using crystals, that could become a monthly injection. So for the same technology, there are many benefits that can come depending on the drug class. So we will be that expert across the board when it comes to crystals. Okay,
really fascinating. Thank you for giving your time and explaining the progress that you and the team have made, of course, and the potential future as well of this technology. Katie King, co-founder and CEO of BioOrbit. That is it for this edition of Bloomberg Tech Europe. In the next episode, we're going to be looking at how Europe's robot revolution is changing the future of work. Join us for that episode, August the 14th, here on Bloomberg Television. That is it for Bloomberg Tech Europe. The Pulse is up next. This is Bloomberg.